So which are the protocols we have in CCNA? Dynamic, OSPF, EIGRP, only two. Okay. So just for your information and knowledge, I'll just try to explain this IGRP, ISIS, and BGP. Okay. Anyway, you don't have it, but just have a knowledge of it. Yes. Not configuration and all, just the information of that one. Understood? So IGRP, Interior Gateway Routing Protocol. So this is what? This is a distance vector or a link state? Vector. It's a distance vector protocol, just like the RIP what we have. It is also a distance vector protocol. So this is a Cisco proprietary protocol. That means only works on the Cisco devices. And as I already said you, it's a distance vector protocol which exchanges the routing tables periodically for every 90 seconds with their neighbors, just like a RIP. What was the RIP timing? What is the hello timer? That was a 30 second. Okay. But here in this IGRP do it for every 90 seconds. Okay. So here also it uses the same Bellman-Ford algorithm just to find the best path or a route computation purpose. Yes. And the metric is what? It's a composite metric. Okay. It's again combination of some other metrics with the hop counts. Okay. So the default AD value for the IGRP is what? 100. What was for RIP? 2. 120. Yeah. 110. Good. 90. It's 120. Somebody says 90, somebody says 110. For IGRP it is a 100. So maximum support the IGRP, the hop counts. Okay, what was in RIP? It was just 15. And here it is 255 hop counts. Okay, so it is a classful routing protocol, just like OSPF. OSPF classless, right? What about RIP? RIP classful. Are you sure? Forget. Version 1 support. Classless. Okay, and this is IGRP. This is totally classful routing protocol. So that is the reason we went for EIGRP. Okay. So later in the year, I guess I'll tell you. Okay. So Cisco introduced the EIGRP as an enhancement to the IGRP, offering faster convergence, support for a classless routing, and more advanced features. Okay. So this is some very small information about the IGRP. Okay. Next we have ISIS, which is a hybrid protocol, right? You said yes. It is a link state protocol. Okay, just like what? Just like OSPF, we have a ISIS. I hope you know that, you remember that. In distance vector, we have two dynamic protocols. One is RIP and second, this IGRP. And link state, OSPF and ISIS. And in hybrid, we have only one, that is a IGRP. In path vector, BGP. Okay, don't forget those. So intermediate system to intermediate system protocol. It's a link state routing protocol designed for use within an autonomous system. which is used within the autonomous system, and it also uses the same algorithm that the OSPF use. What was the algorithm? Shortest path first, or a Dijkstra algorithm to compute the best routes if it has multiple. And here also you don't get no periodic updates. It will also give what? Triggered updates or a incremental updates. Yes. So it sends the updates only when the changes occurs in the topology, reducing the bandwidth usage. Obviously, it is going to use, reduce the bandwidth usage. It's not like a RIP. Okay. For every time, for every 30 seconds, it's gonna use that bandwidth. Okay. So here it only give the periodic. It's not only it's not to give the periodic update. It will give what, like incremental update or a triggered update, I can say. Yes. So link state routing protocol designed for what? Large scale network like a ISPs. Basically this is used as what? In a ISPs or a complex network. Okay. Within the same AS. So it operates at the layer 2 independent of the IP transport, and it supports hierarchical routing with a level 1, that is nothing but intra-area or both inter-area routing. Okay. Where you are seeing the areas? OSPF. Okay. So that also supports the inter and intra-area routing. So it uses a cost-based metric for path selection, manually configurable. What was the metric for the OSPF? Cost only, right? So here also ISIs use the same cost value for the route computation purpose. Okay, so it is ideal for what? Large network due to its efficient updates and the flexibility, and it utilizes some hello packets, LSPs and SNPs for neighbor discovery and the data synchronization. What you have seen in the OSPF, LSAs and LSDB. Okay, LSDB is nothing but what? Link state database, which is having the LSAs. So here also it will be exchanging some of the LSPs or SNMPs just to find out the who is my neighbor. Okay, just to create the routing table. Okay, and it is backbone routing for ISPs and large network environments, as I said you, and it is similar to OSPF but without the need of backbone area. Which is called backbone area? Area 0 is called as a backbone area, where in OSPF you are seen like every router should be the member of area 0 or a backbone 0. Okay, sorry, backbone router, but here it is not compulsory in ISIS. Okay. We are not using this protocol. Sorry? We are not using this protocol. We are not using. Yes, I mean, this OSPF is giving advanced features as compared to this ISIS. So that is the reason we just left this IGRP and ISIS. Yes, still some of the, what do you call, enterprise, they use this one. Okay. It is not totally gone, just like the RIP and IGRP. Okay. Next is what? It's a BGP, Border Gateway Protocol. It is a path vector protocol routing protocol used to exchange the routing information between the ASs, that is the autonomous system on the internet. Basically, it is used between the ASs. Between ASs means what? Just like some between the ISPs or internet and ISP. Yes. And routes are selected based on the path attributes, including AS path, rather than the simple metrics just like a hop count or a bandwidth. The metric of this BGP is what? We have a lot of metrics here. We have 12 metrics in this BGP. Okay, we have how many? 12 metrics. Okay, but the main metric it uses is AS path. Okay, autonomous system path. I mean, whenever the router give its routing table, with that it will give the AS path, autonomous system number with that one. Okay, this is my autonomous system. Please keep it with my router. Okay, that will be very helpful to reach me out later. Yes. So it uses a TCP, that is port number 179 for reliable communication between the PS, and the protocol number is also what? 179. Okay, and there is there are two types of the BGPs. One is a eBGP and second is a iBGP. eBGP means what? External BGP, which exchange the routes between the different ASs, and iBGP means what? Internal BGP, which exchange or shares the routes within the same AS, and it supports what? Classless routing. Obviously, it is a advanced routing protocol. Then it has to support what? Classless routing. Okay. So these are something about IGRP, ISIS, and the BGP. Clear? Next, we'll start with the EIGRP routing. What is EIGRP? EIGRP stands for Enhanced Interior Gateway Routing Protocol. It is an open standard routing protocol, but earlier it was a Cisco proprietary protocol. What I said, nowadays it is called as what? Open standard. But initially, who found this one? Cisco in the year 2013. Okay. So later they declared it as what? An open standard protocol. That means every vendor can use this one. Okay. Not only on the Cisco devices, we can run it on every vendor. Okay. So it's a layer 3 protocol and the protocol number is what? 88. What was the protocol number of REP? 89. Then what about the OSPF? 89. OSPF is 89, okay? RIP? RIP 520. Very sure. OSPF 520. See, port numbers. Let me tell you one thing. Port numbers and protocol numbers, they are really important. When we use port numbers and why we use port numbers? These port numbers will allow you to know that which services it is using. Okay, in which layer? In which layer? Transport layer. Okay, so which service it is actually using, just to know that one, this port number is really important. Understood? So which comes under some well-known port numbers, as I said you. What is the range of that one? 1265. Well-known. 02? 1023. Okay. So this EIGRP is a hybrid routing protocol because it has a feature of both distance vector and a link state routing protocol. Yes. So it is also known as what? Advanced distance vector protocol. Why it is called advanced distance vector protocol? Because we just enhance some extra features in the IGRP. What is IGRP? It was a distance vector protocol, right? So that's the reason this EIGRP is called as what? Advanced distance vector routing protocol. Okay. And this is what? Interior gateway protocol, which supports the classless routing. Understood? And it sends the triggered updates. It means EIGRP router doesn't send a periodic or full routing table information. It will send the update only when the change will occur in the topology. Just like what? Just like OSPF. Okay, what the OSPF will do? It will send only triggered updates or the incremental updates. Whenever the topology change takes place or occurs in the topology, then only it will flood the same, that only that information that will flood to the all routers. Okay, it is not like what? Not like RIP. So what it will do, for every 30 seconds, it will send the entire, what do you call, routing table. But this OSPF and EIGRP doesn't do that. It will not share the entire routing table. It will just send the information or the update, what it is added recently. Okay. So obviously there we are using the bandwidth efficiently in both OSPF and what? EIGRP. Okay. So it uses a algorithm called dual diffusing update algorithm. Diffusing update algorithm. Okay. So to determine the best path in the topology. So in EIGRP, if two routers are configured with the same AS number, then neighborship will be formed in between them. So here, just like what we have seen in the OSPF, there it was the area. If the areas were different, then the routers will not exchange the routes between them. Okay. So same like in EIGRP, if the AS numbers are different, then those routers will not exchange the routing table with each other. Okay. So that is the reason. If you have AS numbers same on all the routers in the EIGRP, then only they will be having the same routing table. Okay. Otherwise, they'll not have. Okay. So it sends a message using the multicast address called 224.0.0.10. This is what? A multicast address to send any update to the other router. Okay. Now tell me, what is a multicast address we use in a RIP protocol? Why? Then what about OSP? If it is that is used in a RIP. Yeah, I can tell you 224.0.0. Tell me next. Zero. It's 9. Okay. And EIGRP 224.0.0.10. OSPF 224.0.0.
4 and 5.
4.
4 and 5.
Five,
Sorry, 5 and 6.
5 is used by DR. Sure. And 6? No. 6 for DR and BDR. Five is used for exchanging the hello packets, and 6 is used for exchange the update from DR and BDR. Okay. Don't forget these multicast addresses. These are really important. Okay. If you want to pass your mock interview. So convergence time is really good as compared to the RIP. Why? Why convergence time is really good? Because there the flush timer is 240 seconds. That means we have to wait for 4 minutes almost. Okay, just to change the topology. But here we don't need to do that one. We just need to wait for 15 seconds. After that, the topology will be changed here logically. Okay. So it is reliable protocol because it provides the acknowledgement of updates. So here it uses one extra protocol that is called as what? RTP, Reliable Transport Protocol, which is going to ensure that the delivery and the acknowledgement of the EIGRP packets. What the EIGRP will do? For every EIGRP packets, it is going to seek for what? Acknowledgement. Okay, for that it uses one protocol called RTP. What is RTP? Reliable Transport Protocol. Okay, so it uses some timers, just like what? Hello timer and the hold timer, wherein hello timer is what? Just 5 seconds, and hold timer is of just 15 seconds. Okay, so it is gonna wait for only 15 seconds. After that, it's gonna remove or flush out that route. And we have two AD values here. First one is internal route. For internal route, it is 90, and for external route, it is a 170. Okay, because it is working in a different ASS, it deals with a different ASS. So if the route which is coming inside or within the same AS, then at that time it's going to give the AD value as 90. And if the route is coming from different AS, then it's going to give that AS as what? Sorry, AD value is what? 170. Okay, these are the AD values we use in a EIGRP. And it supports both equal and unequal cost load balancing. And it maintains 3 types of tables on a router. Okay. So what are those tables? What are the tables? Yesterday also I said, first one is what? Neighbor table. Second one is topology table. And third one is what? Routing table. Routing table. Okay. So these are the 3 tables which both maintains. Both means what? OSPF and EIGRP. What you are seeing in the OSPF. So that also maintain the same 3 tables. So what is neighbor table according to you? What is neighbor table? The routes which are directly connected to the router. So that will be maintained in the neighbor table. What about the topology table? It will be having the complete entire topology into this topology table. And routing table, which are the best routes, okay, according to this topology table. Okay, so you can see the same thing here. So before that, we'll see what is AS, autonomous system. It's a collection of connected network that operate under the single administrative domain and follow a common routing policy. I can say if you want to route the data between some routing protocols, this is called as what? AS. Okay, for example, I said you yesterday, one whole AS will be there. Inside there's some multiple areas will be there. So those areas will be having some different routing protocols. Okay, so routing between this different routing protocols or a different administrative domains. Okay, we can have this autonomous system. Okay, so what I said, it's a collection of what? Connected network that operate under a single administrative domain, which follows some common routing policies. Okay. So the 3 tables I said, neighbor table, second one is a topology table, and third one is a routing table. First one, it maintains the information about the directly connected EIGRP neighbors. So where it will be having neighbor's IP address, interface used to reach the neighbor, and hold timer. Why we use maintain this hold timer? Why we exchange the hold timer? Yes. It is time that will be used for what? Declaring the neighbor is totally done. So it's gonna wait for only 15 seconds, and after that it will be done. If it is not replying for what? Hello messages. Okay. So it uses some timers in, it gives some time strips here to smooth round trip time, SRTT, and retransmission timeout, which are used for reliable packet delivery. I said it uses one RTP, right? RTP. What is this RTP? Reliable transfer protocol. Okay. So just to have this one, we have to have some times, just like SRTT and the RTO. Okay. That's what I said. It is used in a reliable packet delivery. Okay. So second one is what? Topology table, which stores all routes learned from the neighbors, including successor and a feasible successor. Okay. So when it comes to EIGRP, these 2 are really important. They may ask like, what is successor and what is feasible successor? That means what? Successor means what? Best route, and the feasible success means what? Backup route. Okay. So this topology table will be having the contents like destination network, and then the advertised distance. What is the distance between these two? Okay, whether it is a what do you call, internal or external. Okay, within the same years, or it is coming from the different years. Okay, so that advertised distance will be there, and feasible successor distance, which is calculated by the router again, and then successor and feasible successor information. I mean, which is the best path we have and which is the second best path we have. Okay, and the last one, that is the routing table, which will be having only successor routes. That is nothing but the best routes to reach the destination. Okay, you can see here it contains the best route, that's nothing but the successor chosen from the topology table. Okay, so it will be having the successor, destination network, and the next hop and the outgoing interface. Understood? So these are the three tables which the EIGRP maintains. Clear? Are you okay? This how this looks like. Same, right? I mean, it's the same. Yeah, are you practicing? Practicing lab? Yes, you did. That is great. Got your laptop? How many? So we just try to do it on the routers today. Now, class, okay? After this, EIGRP. Then, yeah, now we will quickly configure this EIGRP and directly we'll go to the routers. Yes. So, what you have to do again? What's the word? So, router EIGRP, if I say question mark, it says like autonomous system number. As I already said you, if the routers are in the same autonomous system number, then only they will exchange the routes. Okay. Again, if they are not, again we have to use for what? We have to go for the BGP. Yes. So now I'm going to give the autonomous system number as 1 and then enter. And on what we have to give what? The network, what you have to advertise 192.168.1.0. If I say question mark, it asks for what? Wildcard bits. Now tell me what is a wildcard bit? Nothing is there, just enter. Next, one more. Oh, that's it. Okay. So let's go to the second one and router EIGRP1 and network 192.168.2.0 with the 0.0.0.255 and enter, and one more, that is 4, and you can see there adjacency found, and one more, that is a 5. Done. Okay, you can see here neighbor exchange, okay, with the help of what? Dual algorithm. Okay, neighbor is 192.168.4.1, okay, which is the highest IP on that router. Okay, so new adjacency, that is 192.168. Sorry, I have given that one. So let's do one thing. Let's keep this router into different AS. So let us check like it is gonna exchange this data or not. Okay, I mean routing table. So just give it as router, not right, EIGRP2. Okay, just say network 192.168.5.0, 0.0.0.255, and one more, that is 3.0. Clear? Done? Great. So you can see here, no adjacency message found here. When they are given, no adjacency message is found. If you check it here, so IP route, it will be having only one route because of that EIGRP. There it is. D. D means what? EIGRP. Okay. So which is having 192.168.1.0, and what is 90? It's AD value, internal. And this is again related to metric, the what do you call, calculation will be there. And which is connected via 192.168.4.1, and this is what the exit deface is. Clear? Can you see any 5.0 network? Sorry, the 3.0 network? No. If you check it on the first router, to IP route, there it says I have only one route, sorry, two routes because of that EIGRP. Okay, one is 2.0 network and second is a 5.0 network. Okay, why 5.0 network is coming here? Because 5.0 network is directly connected to the router 2. The only route it is not getting is 3.0. Okay, so here also you can see the AD value is as 90. Okay, and this is again the calculation that's a advanced part. Yep. So if you check the third router, and so what routes will be here? What routes will be here? in this routing table? 354. Pretty sure. Hmm? Only directly connected routes 3 and 5. Okay, so 3 and 5. Only two routes are there. Why? Because it says that I'm into different AS. Okay, and those two routers are into different AS, so they are not exchanging their routing table with me. Okay, so that's the reason I'm having only two directly connected routes here. Clear? So let's change that one. Let's see. So router EIGRP, let's say no router EIGRP2 and router EIGRP1 on network 192.168.3.0 and 5.0. Done. Now we can say neighborship got established. Okay. Now if you check to IP route, there it goes. It is having three routes, 1.0, 3.0, sorry, 2.0 and the 4.0. Okay. Now if you check the connectivity, yes, obviously they're going to ping. The desktop command prompt and just setting 192.168.3.1. Hello, go. So if you check the second one, 2.1, so that will also be pinging. So take out your laptops first. राउटर वर्किंग है क्या? चेक किया आपने? चेक किया? पावर केबल लिया है इन्होंने? थैंक यू. See, somebody connect. I mean, I want how many? 5 laptops. Okay. Ekar, you have two will connect to the console of this. I mean, I need one more. You have? You have? Bring it. You got you don't? You can take console. Mr. Narendra and Vaishnav. Narendra. Narendra, am I audible? I hope you know what to do. Yes. Or else you just do one thing. You want it recorded. Okay, now I'm going to switch. Yes, I think, yeah, it's a switch. So on this one, what we're gonna do? Yes, what we'll do? As I'm asking something, you want me to create some VLANs on switch? Yes. Close it and open the putty again. Okay, enable and config T. How many I have to create? How many pieces I have here? You want pieces free. Free. He can connect to the switch, right? I'm gonna make those into VLANs. LAN cable we have here, right? So bring some more. Okay, listen. So better we'll do one thing. We'll not configure this switch first. We'll just try to assign the IP addresses to this router, and then we just connect to these devices. Okay, let's make these devices separate in different network. Okay, so I'll just remove the switch and give me one router. This one.
So what's the task?
Narendra, I tried to talk to you. You didn't reply me.
Okay.
We were just doing it practically here, and that's what I'm showing you.
In physical routers, huh?
Yeah, on physical routers and switches.
Okay.
Okay. Installation is done, right? Give me the IPs. See, on one network, on one interface, I'm going to use 192.168.1.10, second dot 2.10. That's it. Times it not. Give me one more routers console. More routers console.
Yeah, sir, and the IT, basically 1.1, 192, 160, 1.1, and the there's a focus 1.2 PC, 1.1.
Hmm. Turn off and turn on both the routers. On it. It's not working. Open it and isn't it not connected? Sure, Narendra, you can leave.
Thank you, sir.
Yeah. Both are up.
Yes, sir.
Okay. Now try to assign the IP address of both. What IP address you have given to 1.0.0?
1.10.
1.10. So you have to give 1.0 and 1.
Yeah, 1.1.
You have to 1.1 and gate will be 1.10. Okay, and then you
1.2 and gateway code is
1.2. No, not 1.2. We have given 0/1. What is the IP address?
I did not give, sir. I didn't give it.
Give it, no? Assign 2.1 and 2.10 will be the gateway, and you just give the 2.10 to the this one interface.
Done, sir.
Done. Try to ping with each other. Did you get the IP address? Is your defenders up? Getting? You? Getting? Now, just do one thing. Configure both the routers. Okay. And they will be in different network. Okay. Try to connect them through the switch. Okay. Try to connect these two routers through the switch and then make them in a different network and try to do the routing. RIP, or even you can say OSPF, or even IGRP.
Interface is also
Which interface? Same 0/0, 0/1, and 0/2.
You have to go for.
You are still in the same comport 6, right?
Yes, sir.
So do one thing. Try to go to 0/2.
In 6th one.
Yeah. No shutdown.
Stay down.
Yeah, no, nothing is connected, right? Now cables, these cables, you are connected, right? So just give it to me. Remove this one. Yeah, यहाँ से connect. Yeah, you just give it to 0/0. One more router, 0/0.
This is connected to 5 now, sir.
First give no shutdown. Did you?
Yes, sir.
Yeah, there it is on.
It came down again, sir.
No,
it came up, sir.
Up, right?
Yes, sir.
That is also up. You can see that.
Okay.
Key system.
This one, sir.
This guy. This Shah, Mr. Shah.
It came up, sir.
Came up.
Yes, sir.
Yeah, I know that. Just give IP address and tell him what you're given. What IP address?
The gateway
2.10?
1.10.
2.10.
2 IP 1.10 से निकल.
You said like you are pinging, right? Then
I'm pinging, but we don't not replying song. But when I am pinging to
192.168.1 network.
try to ping your gateway.
1.1 also is fine because it's new router. You give 1.3 then.
Yeah,
Pinging.
This is for a new router.
Then go to.
Both are different.
Not 110. Yeah, we just try to ping 110.
Those are different routers, bro. We gave 1.10 to the bottom one. So now I gave 1.10 to the second one.
Different. No, I can go actually.
What do you want to do?
I want to change the 1.10 to 3.10.
3.10. You are into interface? No IP address, that's it. No. Which interface?
0/0.
No IP address, that's it. Done.
3.0 you want? 3 dots.
So this is the last time I'm showing here. Okay. You can do it on the rack now. Understood? Because the same thing is there on the rack also. Yes. There. Note there. Okay. Understood? You can do it on that rack also directly. I'm not going to show anything there. Understood?
It's done, sir. I've given 3.10 network. Dot 3 network.
Give 3.1 and 3.10 as a gateway. Given. And take one more PC. You have? Okay, then this one. Go to 0.1. For 0/1. अरे उठाओ उसको स्विच को उठाओ 0/1. No shutdown.
Different network or
Different network, right? Obviously. Can give 4.0. Four dot one, 4.10. Wait. It is. It takes some time. Yeah. Assigned IP address, try to ping in.
3.1.
3.1.
Connect date and not of the IP on.
That's what I said you. Whenever you are doing it on here, right? You just turn off your Wi-Fi and even the Defender also. And after completing, check it. Did you get the gateway? Correctly try to ping your gateway first. Are you in a CMD? See, this is what the direct routing it is. That means what? The network which are there directly connected to the router. Then only you'll be able to ping with each other.
4.1 you given, huh?
Gateway what?
4.1 is unreachable. Then check your cable. I think it is.
You're also not thinking 4.1.
Turn off your Wi-Fi and Defender also. Both. Check your Wi-Fi and Defender both. You just try to ping him from the router. 192.168.
We should come out of the conference.
And okay, same. Four dot one. Connected.
Fire or gun matters.
It was not identified. Hey, you can tell now. Hold on. What's the fault?
It came up, it connected, so yeah. Ping 4.1.
Yeah, he is pinging. I'll check out. Yes. Okay, this is what? Direct routing. Okay, tomorrow or else I'll just leave it as it is. Okay, so what you can do, you just connect these, whatever the things you are connected to the PCs, no, directly connected to the switch. Okay, and they will be in a, what do you call?
Different networks.
Different network. Okay, and try to connect your PCs to the
Switches.
switches. I mean switch. Okay, and try to do the routing. Got it? With the help of PRIP or OSP for a user. Got my point? Yes? Yes. Who is on or done? It's down. I think he removed. Who is on or 10? 1.1. Not up. It's not up. Check your 2.1 is thinking. Not 1.1. 2.1. Why did you remove? Yeah, now it is. Okay. So you can practice here also, or else you can go there also. But just do practice. Understood? Everyone? Okay, then we'll end it here today. Okay, I'll just keep this everything here. If you want to practice, you can do it here. Yes, if you want it. You want it? Okay, you can do it.